Students, welcome back to our YouTube channel. My name is Teacher Mati, and today we're going to look at Newton's law of motion. This is a chapter in Form 3 Physics syllabus, and as lesson 1 we're going to look at derivation of Newton's second law of motion. So Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the force applied and always takes the direction of force. So from this definition we have the keywords that we're going to look at before we derive this formula. So we have the rate of change of momentum and the force applied. So we are going to see how the rate of change of momentum relates with the force. Now it is also called the law of momentum. So Newton's second law of motion is also called the law of momentum, or the law of momentum, because it has the momentum parameter. Momentum can be defined as the product of mass and velocity. So if an object is moving or an object is in motion, that object has a specific mass, and if it is moving at a specific velocity. So the momentum of that object will be calculated as the mass times the velocity of that object. Momentum is denoted by letter P, and its SI unit is kilogram meters per second. So when we are dealing with Newton's second law of motion and you see letter P, it means momentum, and because it is the product of mass and velocity, the SI units becomes kilogram meters per second. So the change in momentum is given by mv minus mu. Now if an object is in a specific position when it's moving, at that specific position we can take it as the initial momentum, and its initial momentum will be mu, mass times the initial velocity. And if that object has moved or has covered a given distance and it has a final velocity, then momentum at that particular point will be mv. Now to calculate the change in momentum, we just subtract the final momentum from we subtract initial momentum from the final momentum. So but the rate of change of momentum is given by mv minus mu divided by the change in time. Remember that the change in velocity is taking time, so if we include that time, we'll be having the rate of change of momentum. So the rate of change of momentum is the change of momentum in a specific time. This equation can be rewritten as the change in momentum. So dp is the d means the change, can be written as m. So we can factor m out because mass is the same, and we have v minus u divided by the change in time. And from linear motion we know that final velocity minus initial velocity divided by time is the acceleration. Therefore the change in momentum can be given by the mass of that object and its acceleration. So it's the product of the mass and acceleration. And from the definition of the second law of motion, we said that the rate of change of momentum is directly proportional to the force applied, meaning this rate of change of momentum, which is ma, will be equal to the force. So ma will be equal to force. So the rate of change of momentum is equals to F, and F in this case is the force applied. So from there we reach to our final equation, which is F is equals to ma. So F is the force applied, mass, m is the mass of the object, and a is the acceleration of that object. And remember, our acceleration is given by v minus u divided by change in time, and this one we derived it from mv minus mu divided by change in time.